Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that combines geology, seismology, and a healthy dose of scientific curiosity: the Long Valley Caldera in California. Many of you might already know California for its stunning coastlines, vibrant cities, and yes, its earthquakes. But nestled in the eastern Sierra Nevada, there's a geological feature that quietly hums with a different kind of power, and it's been showing some interesting signs of life lately. We're talking about a supervolcano, folks, right here in the United States. Now, before anyone starts picturing Hollywood-style disaster movies, let's ground ourselves in science. The Long Valley Caldera isn't erupting, nor is it predicted to imminently. However, it's a living, breathing geological system, and scientists are constantly monitoring its pulse. Recent seismic activity has sparked renewed interest and, for us, a fantastic opportunity to understand how these colossal systems work and what signs scientists look for when a volcano experiences unrest. So, what exactly is the Long Valley Caldera? Imagine a giant elliptical depression, roughly 20 miles long and 10 miles wide. This isn't just any valley. It's the collapsed remains of a massive eruption that occurred about 760,000 years ago. That event was truly enormous, spewing out over 150 cubic miles of volcanic material. That's enough to bury the entire state of Rhode Island under a mile of ash. This ancient catastrophe created the caldera we see today, and beneath its surface, there's still a significant amount of molten rock or magma that continues to influence the region. The caldera is part of a larger volcanic field, one of the most active in California, and it's under constant surveillance by the U.S. Geological Survey, specifically the California Volcano Observatory. Their job is critical: to understand the processes driving volcanic activity, assess potential hazards, and provide timely warnings if conditions ever change significantly. For students and aspiring scientists, this is a prime example of real-world geological monitoring in action. Now, let's get to the recent buzz: seismic activity. Earthquakes are a common occurrence in California, but within a caldera, they take on a different meaning. When we talk about seismic activity in the context of a volcano, we're often looking at patterns and characteristics that differ from typical tectonic quakes along fault lines. In Long Valley, scientists have been observing swarms of small earthquakes, sometimes hundreds of them over a period of days or weeks. These quakes are usually shallow, often less than a few miles deep, and many are too small to be felt by humans. So, what do these quakes tell us? Well, they can be indicators of several things. One primary theory is that they are caused by the movement of magma or volcanic gases beneath the surface. As magma shifts, or as gas and fluids move through cracks and fissures, they can stress the surrounding rock, leading to small fractures and, thus, earthquakes. Think of it like water trying to find a path through a sieve. It creates pressure and small disturbances as it moves. Another factor is hydrothermal activity. The Long Valley Caldera is rich in hot springs, fumaroles, and geysers, all powered by the heat from the underlying magma. The movement of superheated water and steam through the shallow crust can also induce seismic activity. These fluids can pressurize cracks, leading to minor faulting and earthquakes. It's a dynamic underground environment where heat, water, and rock interact in complex ways. Beyond just earthquakes, scientists at the California Volcano Observatory use a suite of tools to monitor the caldera. They look for ground deformation, changes in the shape or elevation of the land surface. Imagine a giant balloon inflating or deflating underground. The ground above it would subtly rise or fall. GPS stations and satellite radar interferometry, or InSAR, can detect these minute changes with incredible precision, often down to millimeters. Uplift or subsidence in certain areas can signal changes in the volume or pressure of magma or fluids beneath. Gas emissions are another crucial piece of the puzzle. Volcanic systems release various gases, primarily water vapor, carbon dioxide, and sulfur dioxide. Changes in the type, quantity, or ratio of these gases can indicate renewed magma ascent or other subterranean processes. Scientists collect gas samples and use remote sensing techniques to measure these emissions, looking for anomalies that might suggest increased activity. So how worried should we be about this unrest? The scientific consensus is clear. These signs of activity are normal for a restless caldera like Long Valley. It has a history of inflation and deflation, and seismic swarms are a known part of its behavior. In fact, the caldera has experienced multiple periods of unrest since its last major eruption, including notable episodes in the 1980s. These events ultimately did not lead to an eruption, but they provided invaluable data for understanding volcanic processes. The key takeaway for students and anyone interested in geology is that volcanic systems rarely erupt without giving numerous warning signs. These aren't sudden, unpredictable events in most cases. Instead, they often follow a progression of increasing seismicity, ground deformation, and changes in gas emissions over weeks, months, or even years. The scientific community is highly vigilant, using sophisticated instruments and detailed analyses to interpret these signals. For those of you considering a career in earth sciences, this is a perfect example of applied geology. It involves fieldwork, advanced data analysis, remote sensing, and collaborative efforts among geologists, seismologists, geochemists, and geophysicists. The goal is not just to predict eruptions, but to understand the fundamental forces shaping our planet and to mitigate risks to communities living near these powerful natural features. The Long Valley Caldera continues to be a fantastic natural laboratory for scientists. Its ongoing seismic activity is a reminder that our planet is constantly active, and understanding these processes is vital. It challenges us to refine our monitoring techniques, improve our models of subsurface dynamics, and educate the public about volcanic hazards in a responsible way. In conclusion, while the Long Valley Caldera is experiencing seismic unrest, it's a part of its normal behavior as a living volcanic system. Scientists are closely monitoring every tremor, every millimeter of ground change, and every wisp of gas. This isn't a cause for alarm, but rather a fascinating opportunity to learn more about one of Earth's most powerful and awe-inspiring geological features. Thank you so much for joining me on this deep dive into the Long Valley Caldera. If you found this information insightful, please hit that like button, subscribe to the channel for more science content, and let us know in the comments what other geological wonders you'd like to explore. Your engagement helps us bring more awesome science to you. See you next time.